be doing chapter 2 on chemistry and measurements. We start with number 1 that says write the equality and 2 conversion factors for each of the following pair of units. How many sig figs are in each conversion factor? Think measured number versus exact number. Remember that measured number, if we refer back to our textbook, says that a measured number are the numbers you obtain when you measure a quantity such as height, weight, or temperature. And our textbook also states an exact number is something you obtain by counting or using a definition that compares two units in the same measuring system. If we refer to our textbook on page 38, 2.5, there is a table that contains some common qualities. So for letter A, we need 1 meter to a millimeter. We know that if you take 1 meter and divide it by 1,000, it will give you your millimeter. So if we have 1 meter, divide that by 1,000, we get 0.001 millimeter. We know that millimeter is 1,000 units smaller than a meter. And our sig figs would be infinite. Now we need day to hours. 1 day is equivalent to 24 hours. We'll have to remember to write our milliliters and our unit of measurement. Our sig figs here could also be infinite. Now we need pounds to kilograms. We can also refer back to the table on page 38. We see that 1 kilogram is equivalent to 2.20 pounds. For this one, we look at the measured unit, and the smallest one that we have is the pounds. We count the sig figs. 1, 2, 3. 3 sig figs. Number 2. Write the equality and 2 conversion factors for each of the following statements. How many sig figs are in each conversion factor? Letter A. The label on a bottle reads 10 milligrams of furosemide per milliliter. 10 milligrams of furosemide per milliliter. So we know that 10 milligrams of furosemide is equivalent to 1 milliliter. 2 conversion factors could be 10 milligrams per milliliter, or 1 milliliter per 10 milligrams furosemide. Our sig figs here, we look at 1, 2, 3 sig figs. For B, an IV of normal saline solution has a flow rate of 85 milliliters per hour. 85 milliliters of saline solution is equivalent to, per 1 hour. Our conversion factors are 85 milliliters saline solution per 1 hour, or 1 hour 85 milliliters of saline solution. For C, silver coin contains 58% by mass silver. When we see percent, we always have to think of 100 out of 100. So we have 58 grams of silver per 100 gram coin. Our conversion factor will be 58 grams of silver per coin, which is 100 grams. And we're doing it in grams because it is asking for mass. Or we can have 100 grams per coin over 58 grams of silver. Number 3. A physician has ordered 0.50 milligrams of atropine intramuscularly. If atropine were available as 0.1 milligrams per milliliter of solution, how many milliliters would you need to give? How many milliliters? So we're looking for milliliters, and our given is 0.50 milligrams of atropine. So this is our given, this is what we need. We need milliliters of solution. Our conversion factor will be right here, 0.1 milligrams atropine per 1 milliliter solution. In order for us to solve, we are going to use our conversion factor and our given. So we begin with our given, which is 0.50 milligrams atropine. We want to go from milligrams to milliliters. So we want to get rid of milligrams. So we know we're going to have milligrams here, so this can cancel out. We know that 0.1, we're using 0.1 because it's our conversion factor, because that's what we know, per milliliter. So we're going to put 1 milliliter of solution on top. This cancels out, and we multiply across, and when you multiply, you get 5 milliliters of solution. And we always have to remember to write our units because we can easily mistake milliliters for milligrams. For B, it says an intramuscular medication is given at 5 milligrams per kilogram of body weight. What is the dose for an 1,800-pound patient? Our given is 1,800 pounds, and we are looking for what is the dose? So we're looking for how many milligrams per kilogram. So we need milligrams needed for the patient, and our given is the 1,800-pound patient. Our conversion factor will be right here, 5.00 milligrams per kilogram. So to begin, remember we always begin with our given, so 1,800 pounds. And remember, we want to get rid of pounds, so we know that pounds we want to put down here to get rid of. So we need to go from pounds to kilograms. We can use our chart also on page 38 of our textbook. And we see that 1 pound is equivalent to 0.454 kilograms. And now that we have kilograms, we want to go to milligrams. So we're going to put kilograms here. So this can cancel out 1 kilogram. And we want milligram. And we know, because of our conversion factor, we have 5 milligrams per kilogram. And then these cancel out, and we multiply across, and we get 4,086 milligrams. Is it asking for the sig figs? No. If we were to do the sig figs, or if you want to round actually, it would be 4,100 milligrams per medication. So it didn't specify the medication. C states the physician has ordered 1 gram of tetracycline to be given every 6 hours to a patient. If your stock on hand has 500 milligram tablets, how many will you need for 1 day's treatment? We're looking for how many tablets we will need for 1 day. And our given is the 24 are given for 1 day. So 1 day we know is 24 hours. So I already see that we're going to have to go from hours to grams to milligrams. So the way we do this is our given is the 24 hours, so the 1 day, and we need to find how many tablets. Our conversion factor that we are going to be using is the 1 gram of tetracycline per 1 hour. Also, 500 milligram tablet. 500 milligram of the tetra is equivalent to 1 tablet. Remember, we always begin with our given, so we know 24 hours. We want to get rid of hours, and we also were given 6 hours. So in 24 hours, we need to divide that by the 6 hours, because we want to know for the patient is given every 6 hours. Per 6 hours, the patient is given 1 gram. We also have our conversion factor right here. And this gets rid of hours. Well, now we have grams, and we need to get rid of grams because we want to find the actual tablets, not the grams. So here we're going to put grams per milligram. We know that 1 milligram is equivalent to 0.001 gram, and I know this because also the chart, but another way is we know that milligram is by 1,000. So we take 1 and we divide it by 1000, we get 0.001. So we put that number right here. This gets rid of the grams. Now we need to go from grams per tablet. And we have that conversion factor right here. This gets rid of our milligrams. We are left with tablet. So we take 24 divided by 6, take that, divided by 0.001, take that, divided by 500. If we do that in your calculator, you will end up with 8 tablets. Number 4, density. What is the density of the solid object that is weighed and submerged in water? So we are trying to find the density of this object. We know that the formula for density is mass over volume. And remember that grams is a measurement of mass and milliliters is a measurement of volume. To begin, we want to find the volume. So we want to subtract this from 18.5, 23.1 milliliters minus 18.5 milliliters. You will end up with 4.6 milliliters. This would be the volume of the object. Mass is 8.24 grams over the 4.6 milliliters. Our density will be, if you do that in your calculator, you will end up with 1.8 grams per milliliter. Number 5. Gasoline has a density of 0.74 grams per milliliter. If I filled up a bottle with 505 milliliters of gasoline, what would the mass of the gasoline be? So right away we see that we are trying to find mass. So we are looking for grams. We are given 505 milliliters and we are given the conversion factor 0.74 grams per milliliter. We begin with our given. This is our conversion factor and this is our needed. So we begin with 505 milliliters. We want to get rid of milliliters, so we put per milliliter. Per milliliter, we have this conversion factor, so we put 0.74 grams. Grams, milliliter, milliliter. You type that into your calculator, you will get 373.7 grams. That rounds to 370 grams. So that's chapter 2, chemistry and measurements.